In this video, I will go through questions about functions. We'll go through questions that are just about functions in general, and then we'll go into exponential functions and linear and exponential scenarios, and then average rate of change. Okay, so the whole gamut of questions about functions. Number one, add a value to the empty cell in the table below so that it will still represent a function. So I see a table with x values, inputs, and f of x values, outputs. And I see there is one place in the table that is empty. There is no value for an output for 2 in that row on the table. Okay, so let me think of a definition of a function. Every input can only have one output. Okay, so if 1 is an input, right, in that first row, and it matches to 0, then the only way this can be a function is if every time I see 1, the output is 0. Next row says 2, 3. So an input of 2 always gets an output of 3. Next row says 2 again. Well, if I want this to still be a function, then the only output I could put there is 3. Okay, because I already have the input of 2 and it went with 3. So the next time I see an input of 2 has to also go with an output of 3. And this way, this table is still a function. 2. The graph of f of x is shown below. So we have a graph and this is a function. And our question is, what is the value of f of 5? So what does that question mean? Well, if there's 5 inside, that means I'm telling you that x is 5. So I want to know when x is 5, what is the output or the y value that goes with that? So here's 5 on my x or my input axis. And I'm going to find the point that goes with that, and that's right here. Input of 5, output of 4. So the value of f of 5, the output for an input of 5, is 4. Another very similar question, what is the value of f of negative 2? So now I'm looking at an input of negative 2. Pause the video and answer this yourself. Okay, for an input of negative 2, I see the point down here, negative 2, negative 6. So input of negative 2 gets us an output of negative 6. Next, I asked you to evaluate a function from an equation. So now we have an equation for a function that says x squared minus 6 times square root of x. And we're evaluating f of 4, an input of 4. So once again, we're figuring out the output for an input of 4. Inputs, again, are x values. So that means that I'm going to take this x squared minus 6 root x, and wherever I see x, I'm going to substitute 4 because I'm doing an input or an x value of 4. So let me put 4 in there both times that I saw x. And now I need to simplify this. I'm going to follow PEMDAS, right? Parentheses, exponent, multiply, divide, add, subtract, order of operations to simplify this. I don't see parentheses. I do see an exponent. The exponent is 4 squared, right? 4 squared means 4 times 4, which is 16. There's actually another exponent because when you see a square root, that's also in the same family. It's the opposite of an exponent, actually taking the root. So we're going to do that before we multiply. We're going to take the square root of 4. That's asking us what number do you multiply by itself to get 4, and that would be 2. So that is 2. And now we're going to multiply. 6 times 2 is 12. And we have 16 minus 12. Now we will subtract. 16 minus 12 is 4. So an input of 4, when we substituted everything, all the x's with 4, we got an output of 4. Next, we need to write an equation for the data shown in this table, and I will tell you that this is going to be an exponential function. So the form of an exponential function is f of x equals a times b to the x power. A is the initial value, or the starting amount, and b is a constant factor, a number that we keep multiplying by as we go down that table. So the initial value in this case is pretty simple to fill in. Okay, initial value is always when x is 0. When x is 0, I see that the output is 500. So I will put that right in there. Okay, 500 is the initial value. The constant factor is a little harder here. I don't know what I multiplied from 500 to 550. What did we multiply by? Well, if you don't know that, then what you can do is put that into the calculator. I will pull up a calculator right here. And I could take that second number, 550, and divide it by the first number. Okay, I see 1.1. That means that to get from 500 to 550, I multiplied by 1.1. So my constant factor that I'll put into my equation is 1.1. And if I'm not sure that that's true, I could keep going and try to see from 550 to get to 605. Is that times 1.1? Let me see. 550 times 1.1 equals 605. So yes, I see that it worked for the next pair of values also. I continued multiplying by that factor of 1.1. So I know that I have the correct equation. Initial value of 500 multiplied by the factor of 1.1 for each x value. Here is another exponential function, and here I notice from 500 it went down to 450. So I know my factor is going to be less than 1. Okay, if it's decreasing, my factor is less than 1. So let me see, from 500 to 450, I'm going to take that second number, divide it by the first number, and what was the factor? It was 0.9. Okay, it was times 0.9 in order to get from 500 to 450. So now my initial value is also 500, but this time my factor is 0.9. Okay, so that is my exponential equation for this function. Next, we want to know if each scenario is linear or exponential. For a linear scenario, we're going to be adding or subtracting. We have a constant rate of change. For an exponential function, we are multiplying. We have a constant factor. So look through these 4 scenarios and decide which ones are linear and which ones are exponential. Number 1, you earn $10 for every hour you work. This is an additional $10, right? It's a constant rate of change. If I get $10, I get $10, I get $10. So that would be an example of a linear function. Number 2, you receive 5% interest on your money in your bank account each year. Anytime you see a percent, it's exponential because we're multiplying. In order to receive 5% interest, you multiply whatever amount of money you have by 1.05. 500ths is the 5%, 1 to keep the whole amount of money you have. We discussed this in greater length throughout the year. So that is a constant factor. So therefore, this scenario is exponential. Next, we have a colony of ants that triples. Triple means I am multiplying by 3 each day. If I am multiplying, then this scenario is exponential. Lastly, we have you spend $2 on lunch every day. Spending $2, that is a constant amount. I took off $2, I took off $2, and I take off $2 again. Constant rate of change of -2, so that is a linear scenario. Our last problem related to functions is to calculate the average rate of change on the interval 6, 12 for the table below. So remember, whenever we're doing average rate of change, we're always taking change in the y values divided by the change in the x values. But we have to use a specific pair of values. We can't just go to any row on the table and check and subtract the 2 numbers. We have to use the interval. The interval we're given here is 6, 12. Interval is always telling me about the x values that I should choose. So it's telling me to start from 6 and go to 12 and use the pair of values where x is 6 and the pair of values where x is 12 and find the change in y divided by the change in x. So change in y, 84.5 to 256. I will subtract on a calculator. 256 minus 84.5 is 171.5. Okay, so this is an additional 171.5. So our change in the outputs, I wrote y, but here it says f of x, so I should be consistent. Okay, the change in the y, or the output column, is 171.5. From 6 to 12, that's 6 plus 6 equals 12. So our average rate of change in outputs, 171. Change in inputs is 6. So that gets us our fraction for our average rate of change. Now we're going to divide. That 171.5, still in my calculator, divided by 6, the change in the inputs, and we get 28.583. And it keeps going, so we'll just round it and we'll say 28.58 is the average rate of change on the interval from x is 6 till x is 12. And that is everything I have about functions on your final.